The p-value method then is another way of performing the hypothesis test, and p-value stands for a probability value. So the idea of the p-value, or what a p-value is, it is the probability of seeing a sample statistic, such as the mean, or more extreme in the direction of the alternative hypothesis. So really all you're going to do is to compute the probability of a test statistic in the direction of the alternative hypothesis. That's what a p-value is. Okay, that's it. I mean, I'm not going to try to make anything esoteric about this, and you don't have to have special knowledge. A p-value is the probability of seeing the value of the test statistic or something more extreme in the direction of the alternative hypothesis. That's all a p-value is. So if somebody asks you, what is a p-value, all you have to do is come back and say, it's the probability of seeing that test statistic or something more extreme in the direction of the alternative hypothesis. That's all you have to say, because that's all there is to it. So now what we're going to do is, when we compute our test statistic, all we're going to do now is to compute the probability of seeing that test statistic in the direction of the alternative hypothesis. And in this case, our test statistic is a z statistic, so all you got to do is compute a normal probability. So you either use your normal CDF or you look these things up in your tables, whichever you feel comfortable. So when we have a two-tailed test statistic, depending on if the test statistic falls to the left or to the right, the idea then is to compute your p-value here for a two-tailed test. Notice that if this is 0 and my test statistic falls over here, then I'm just going to compute this area over here. But if it's a two-tailed test, then I have to turn around and compute this area here. And again, this is my z test statistic, and this is my z test statistic. But the idea that since I'm having a two-tailed test, then that means I have to compute this probability going this way and this probability going this way. But since the normal distribution is symmetric, depending on which side you're on, all you have to do is compute that probability and double it. Okay, that's all there is to it. Now for the left-tailed test, you only have to do this part, and you're done. For the right-tailed test, you can compute this part, or knowing that the tables give you this part, and using the symmetry properties, you can compute this part over here. So it doesn't matter, whichever way you feel comfortable computing these probabilities, if you're going to look them up in the table. Now, if you're going to use the normal CDF, piece of cake. Just plug them in. Lower bound, upper bound, enter. You're done.